All right, taking a shot at number 13 here. We've got our semicircle, point AB, and we are trying to take this angle here and prove that it's 90 degrees. Nice thing is that it looks like it's 90 degrees. So all we're going to do is just hope that by using the dot product, we end up with an answer of 0. And so let's just define our two different vectors as we go through this and work out what the dot product is going to pop out to be. And so when I look at vector AP here, going from A to P, vector AP is going to be just vector P minus vector A. And similarly, vector BP is just equal to vector P minus vector B. And so whenever you're asked to find that the value of an angle is 90 degrees, you should be thinking, okay, the dot product needs to equal 0. So let's take the dot product of AP dotted with BP. So AP dotted with BP is the same as P minus A dotted with P minus B. And this isn't going to get you very far, but the key insight is that it's a semicircle. And so when it's a semicircle, you know that B is the opposite of A. And so because B is the opposite of A, you can use a substitution right there and get P minus vector A times P plus vector A. And then you get P squared minus A squared. Now, the nice thing about this is, just a second. Now, it might not be clear why P squared minus A squared would have to equal 0, because again, we're trying to prove that these are perpendiculars. But the idea is that if you square the vector, you get the same thing as the magnitude of that vector squared. And one thing that's really nice about this problem is that it's on the semicircle. And if it's on a semicircle, you know that all the points are equidistant. And so you know also that the magnitude of vector P is equal to the magnitude of vector B is equal to the magnitude of vector A. And so using that, you know that this is equal to 0 for any point P on it. So really all we did was set up the dot product because we were trying to prove that there was a 90-degree angle. And then we used the fact that A and B are pointing in opposite directions. So A is equal to negative B. So we use that substitution. And then we use the point that A, B, and P are all equidistant to make it equal 0.